So we're talking about this pancreatic cell that you guys have discovered as the origin for pancreatic cancer. First of all, tell me how this all came about.
There are well known the genes that are the predominant causes of cancer in humans are known. If you take pancreatic cancers from many hundreds of patients, the predominant gene which has gone wrong is well known, called KRAS. And there have been a variety of attempts to find ways of modeling pancreatic cancer in mouse. Because the mouse is genetically exploitable, and you can make hundreds of mice and you can control them and then how pancreatic cancer is formed. It's much easier than doing the studies in humans. You really can't study humans. You try to cure humans, you try to stop cancer forming, but you can't study the process. And so maybe a decade ago, we started to engage in some studies with a person called David Tubeson, who was at the University of Pennsylvania. He moved to England. He's a very famous person in the pancreatic cancer community. Our studies with them were to try and find ways of turning on this cancer-causing gene in a mouse and reproduce pancreatic cancer in a mouse. And the first studies, about a decade ago, like I said, really showed that we knew how to activate this gene in a mouse pancreas. And these mouse pancreatic tissue sections were taken to pathologists, and they were asked, what do you think that looks like? And they were, the researchers were told, we think that looks exactly like human pancreatic cancer. In fact, I think those slides are pancreatic cancer from humans. And they were really surprised when they found that it was from a mouse. So that was a big step forward, because that had not been reproduced so far. It was a sort of watershed or seminal paper, and has allowed us to go further. That paper that was published about a decade ago was the first to really produce a model for pancreatic cancer. But it didn't have any selectivity of which cell type this human cancer-causing gene was expressed in. And what we've done now is use a variety of different tricks to identify the gene which is expressed in specific cell types within the pancreas, and there are basically three types. There are the enzyme-secreting cells, there are the hormone-secreting cells, like the insulin-producing cells, and there are the tubular cells that allow the digestive enzymes to go back down towards the intestine to digest your food. So there are three different cell types, and we've got ways of turning on this pancreas cancer-causing gene from humans in those cells specifically. And only in one of them, which is the enzyme-secreting cells, what are called the Acinar cells of the pancreas, did you get the most effective type of pancreatic ductal adenocarcinoma.
So what does this mean now for the research?
Well, so first of all, we knew the gene that was causing cancer in humans, but we didn't know within which cell type you had to have it active to cause the most aggressive types of pancreatic cancer. And what this allows us now is to generate hundreds or thousands of mice whenever we want, to then study the very first steps of pancreas formation. The initiation of pancreas cancer is one of the most important steps to get into, because that's when we'd like to intersect our drugs or other types of approaches to try and cure cancer in humans. We'll use the mouse as a way of following the very first steps of pancreatic cancer formation, its progression, and we'll use them as a discovery model with drug companies, hopefully, to try and understand the right kinds of pharmacological agents or new molecules to stop the initiation or stop the progression of pancreatic cancer.
So to anyone, Joe Schmo watching this tonight, this could mean possibly finding a way to prevent or cure cancer.
Yeah, I think it's going to do two things. It's going to allow us to find the very earliest markers that someone might display in their bloodstream, for example, or in other types of tissue that says, a warning sign, I might have pancreatic cancer. It's going to allow the definition of new they call blood markers for that. But it's also going to allow us to potentially put new drugs into the market that would get into the human at the very earliest stages of pancreatic cancer, hopefully stop it completely, maybe even revert it to a completely non-cancerous condition. But knowing the cell type in which you have to express this human pancreas cancer causing gene is a really huge step forward, because we didn't know which cell type to really focus on before.
That's what I thought, because I read this article that was in the VUMC Reporter,
Yeah.
and it mentioned that there was another cell that you thought
Yep.
beforehand could have been
Yeah.
what this cell actually
Yeah.
is.
So it's been controversial that the cell of origin for what it's referred to as the cell of origin. So the cell of origin for pancreatic cancer could be what's called the ductal cell type. And that is a cell type which is in these tubes which lead the digestive enzymes down towards the intestine, or the acinar cells. And it was really thought for a long time that it was the ductal cell which was the source cell for pancreatic cancer. It turns out that the acinar cells, these enzyme-secreting cells, change. When they become cancerous, they change into a duct-like cell. So you can imagine that's where the confusion came from in the past. It looked like it was a duct cell that was turning into pancreatic cancer, but it was really the acinar cell disguising itself on the way to becoming cancer as a duct cell. Okay. Right? So now we've been able to push it back. The process has gone backwards, and we found out that actually what happens is the acinar cell starts to go crazy, turns into a duct cell, and then turns into the cancer.
Okay, I see. Okay, cool. Anything else about this that you think people would find particularly interesting or fascinating as this pertains to pancreatic cancer?
Well, I would like to say that I think that the energy and the synergism between three groups working in different parts of the country with funding of the NIH has allowed us to come together as a group. We have meetings twice a year amongst us, and it was only through those meetings that we realized that we might be able to do some of these studies together, and the sharing of some of these mouse reagents and mouse strains that we use to do these studies has been facilitated only by having these meetings. So it's a sort of an idea of how big team science across the country can really come together to create what we hope is a massively important discovery for the community. And we really hope that this mouse gets picked up by the drug companies who are in the business of creating the drugs and pharmacology for human treatment.